Hello guys, welcome to Java Core Programming course. This lecture is 7 and I am going to start section 2. So today's agenda, we are going to discuss relational operators, logical operators, if-else statements and nested if-else statements. Decision making in Java. Decision making is very important. It is fundamental in programs. We make decisions to select a certain statement or a block of statement to execute. There are two sets of operators that are used for decision making: logical operators and relational or comparison operators. These operators are used in logical expressions that evaluates to true or false. Based on those true and false conditions, we take decisions. Relational or comparison operators are used to compare values. The result of comparing is a Boolean value, true or false, that help us take decisions. Their operators are binary. These operators are binary operators. They take two operands to decide. Logical operators are used for concluding logical expressions. The resulting value is always a Boolean value, true or false value, that is used to take decisions. These are the relational or comparison operators: greater than, less than, greater than equal to, less than equal to, not equal to. These are six relational or comparison operators, and these are the results of comparing values. For example, if x is equal to 5 and y is equal to 3, x is greater than y evaluates to true. And if we evaluate y is greater than 5, y is greater than x, it will evaluate to false. Similarly, we will use other 5 relational operators to compare two values and make a logical expression that evaluates to a Boolean value, true or false. And based on that result, we will take action to execute a certain block of statement. Logical operators. 5 logical operators. These operators are used in building logical expressions by combining different conditions. These operators are handy to avoid nested if-else blocks, and we will discuss that shortly. So basically, these logical operators are used to combine multiple conditions to make a complex logical expression. That expression is then evaluated to true or false, a Boolean value, and used to take action. So AND operator, this operator and this operator, their result is same, but their processing different. For example, logical AND combines two conditions. We are comparing x is greater than y and x is greater than z. So and conditional AND doing the same thing, but there is a fundamental difference between and conditional AND operator. In this case, both the conditions are evaluated, no matter first one is true or false. In this case, first one is evaluated first. If the result is true, it goes to evaluate the second logical expression. If this evaluates to false, it just stops evaluating the next logical expression. So it is a basically shorthand or short circuit. If this is true, it goes to evaluate this one. Otherwise, it does not. Same goes for these two. This is logical OR and this is conditional OR. Logical OR checks all the conditions, no matter this one is true or false. In case of conditional OR, if the first is true, it executes the next block or condition or return or evaluate the expression to true. If this is false, it evaluates this one. In case of not operator, it inverses the value of or evaluation of logical expression. If x is greater than y is evaluated to true, not operator it reverses the result and make true to false and false to true. So if statement. So if statement help us decide whether or not to run a single statement or a block of statement. This is general syntax of if statement. In case of single statement to execute, we can skip curly braces. If we want to execute multiple statements within the if block, we used to enclose them into curly braces. This is flowchart for the if statement. This is a condition if expression. This expression is evaluated. If it is true, it executes the if body or if expression block. If it does not, it goes to the next statement. And else class. So else class combines with if statement. In case of if statement, if condition is true, the block executes. If we combine else with the if statement becomes in this form. If expression is evaluated to true, if block is executed. If it evaluates to false, else block will be executed. So in this case, we either execute this one or this one. This is the flow chart. Here, decision will be made. If the Boolean expression is evaluated to true, it will go into the if block and execute the if block. If the decision is false, it goes into the else block here and execute the else block. And then in both cases, goes to the next statement or end of the program. Okay, now nested if statements. We can also nest if-else statements to further branch our code into execution. Look at this flowchart. This is top level if block. If this if statement condition evaluates to true, it goes into this decision loop. Or if it is false, it goes to take this decision. In this condition, it checks true. If true, it runs this block. Otherwise, it goes to next statement or stop the execution. And here same goes here. Condition is evaluated. If it is true, it runs the if block. If it is not true, it goes to next statement or end of the program. So nested if statements help us implement complex logic. This same nested if else statements we can combine with logical operators into a single if else. This is an example. Let me show you the entire syntax. Okay, so if outer if expression evaluated, if it is true, it goes into this if block. This if block condition evaluated, if true, if block is executed. If this expression is false, it goes into else block and else block will be executed. Same way we can add else clause here. In the else clause we can again nest the if else statements. Thank you guys, and let's begin coding to test our concepts. Thank you. Hello guys, let's practice lecture 7 concepts: relational operators, logical operators, and if else statements and nested if statements. Let's begin by creating a class. If statements. Add main method. Entry point of program. Okay, let's practice if statements. What is an if statement? So we need if keyword, parenthesis, condition, and statements. As we studied, this is if statement. So when we evaluate, when the computer evaluates this condition and it is true, the statement will be executed. So let's symbolically run it. Let's say we have a flag, boolean flag is equal to true, and flag is our condition, and it is true, so it will print this statement, dot println I am inside if block. So let's run it. So this will print this statement. Okay, now if it is false, it does not run. Let's put something here. After if block. So run it. So after if block is printed, but this is not printed because condition is false, so it does not enter into if block. Okay, now let's add else class. So else I am inside else block. Okay, this is false, so it will enter into else block. Else block is the block if the if statement condition is not true, this block will be executed. Let's test it. So it is inside else block because the condition is false. So if it is true, the if block will be executed and this block will be skipped inside if block, and this block is skipped. This is after the if block. Okay, now nesting. We can nest if else statements. Okay, let's put another condition. Let's say flag 2, boolean flag 2 is equal to true. Okay, if flag 2, this condition is true, I am inside nested if block. Okay, otherwise I am inside nested else block. Okay, we can copy this and place it here because we can nest if block into else block and if block into if block. So I am inside nested if block and I am inside nested else block. So for our condition is true, so we will enter into this block, and then we have flag is equal to flag 2 is equal to true, so this block will execute and this will be printed. This is printed and this is printed. This will be skipped and this entire block is skipped. Let's test it. Okay, I am inside if block here. then it check the condition of this if statement. It is true, so it enter into this statement, and this one skipped, and then entire else is skipped and it comes here. Okay, now let's swap false. Now flag 2 is false, so it will enter here, print this one, and check this one false, so enter here, and this will be printed. Let's see it. See, this block is here. Now this is false and this is also false, so it will skip this entire statement. It enters here, print this one, check this one, this is also false, so skip it and enter here and print this statement. Let's see. Run the file. So it is inside else block, printed this one, then it printed inside the else block this one. This is how nested if else and if statements work. Now let's test these with the actual statements. Let's test with the relational operators. Okay, let's leave it here. We add new practice relational operators. They are 6: greater than, less than, greater than equal to, less than equal to, and equal to and not equal to. So we have two variables, int x is equal to 5, int y is equal to, let's say, 7. Okay, so we check with the relational expression, logical expression. If x is greater than 7, x is equal to 5, greater than y is equal to 7. So it is obviously not true. So we go into else block and print it here. Less than. Okay, so let's print it. So x is less than, y is equal to 7, this statement, because x greater than 7 evaluates to false. This is how relational operators are used to compare two values. Value of x is compared with value of y, and we have the result as false. So if block will be skipped and it enters into else block. Same way we can check for less than. If x is less than y, so this will be printed. Greater than y. Run the file. So x5 is less than y7. This one, because x is less than y, a value is to true, so this will be executed. Same way we can combine relational or other logical expressions by use of logical operators. Logical operators are 5: AND operator, OR operator, NOT operator, and conditional OR operator or short circuit, and conditional AND operator. Okay. Let's make a statements to test other relational operators. Okay, let's say system.out x is equal to 5 and y is equal to 7. Okay, now less than greater than y is equal to 7. And same way we copy it to test the other 6 relational operators. Okay, this is less than, greater than, equal to, less than, equal to, and not equal to. Less than, greater than, equal to, less than, equal to, equals to, and not equals to. So this will print the results true and false. Let's run it. Okay, here are our output. X is equal to 5 and y is equal to 7, greater than, false, less than, true, greater than, equal to, false, because 5 is not equal to or greater than 7, less than or equal to, one condition is true, less than, so it is true, equal to, false, not equal to, true. This is how we can use all the 6 different relational operators. Okay, now relational operators. Let's say we have x is equal to 5, y is equal to 7, and z is equal to, let's say, 3. Okay, if x is greater than, equal to 7 and x is greater than, equal to z, x is greater than, equal to y, and x is greater than, equal to z, else not equal to. True, false. Declare it because xy is already declared. So run the file. So this is false because this evaluates to false. So how this works? First logical expression evaluated because of and. This is a logical operator. It evaluates 2 logical operators or expressions, and this one also evaluated. This is false and this is true. It needs both must be true. So this is how it works. Truth table. Truth table is, it works like this: A, B, and this is true, false, result is false, true, 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 false, true, false, and false, false is equal to false. So it is only true in case of both the expressions are true. These two, this one true and this one true. What is the difference between and operators? In case of AND operator, it must check this one, and no matter it is true or false, it also checks this one. If we use this operator, if this one is false, it does not check this one. That is why it is called conditional AND operator, or we also call it short circuit operator. So the same way OR operators works. Or either condition is true, this will execute. Let's check. Run. So here AND operator, it returns false, so this one executed. In case of OR operator, any one of these two logical expressions true, this will operate. So this is true because x is equal to 5 and z is equal to 3. So this is true, so it will execute this one. In case of OR operator, both the expressions are evaluated. If we use conditional OR, if this is true, it will execute this one. It does not evaluate this expression. If this is false, it will check this one. And if it is true, it runs this block. If both the conditions are true, it will run this block. So it is like this. And truth table. Or truth table. So let's copy this. These are the values. So true, false, result is true. True, true is true. And false, true is equal to true. And this is only false condition if both conditions are false. So either of the condition or both the conditions are true, the block will be executed, this block. If both conditions are false, this will be executed. In case of conditional OR, if first expression is true, it executes it. It does not evaluate this one. If we use simple OR operator, both the conditions will be executed and evaluated. NOT operator. NOT operator reverses the Boolean result. So let's say we have this one. X is greater than or equal to Z, and it is true. So let's see what will happen when we execute this code. Run, and this is true. Okay, now if we apply NOT operator, this will become false and this block will be executed. See, this is how we combine different relational and logical operators to control over decisions and execute different blocks. These Boolean expressions are also used in loops. We will study them in the lecture for the do, while and other loops. Thank you guys. This is all for today, and please subscribe to my channel and promote the content. Thank you guys. Hello guys, welcome to the Java course programming section 2 and lecture 8. Today's agenda, we are going to discuss ternary operator, switch statement and variable scope. Let's begin. Ternary operator. Ternary operator operates on three operands. The first operand or expression must evaluate to a Boolean value, and it is a logical expression that help us decide which of the second and third operand will execute. Based on the expression, if true, if the expression our first operand is true, the second operand will execute. If the logical expression evaluates to false, the third operand will execute. This is the format. Expression, this is logical expression. If true, this is true block, and this is false block. If the expression evaluates to true, this block will execute. If the expression evaluates to false, false block will execute. This operator is equivalent to an if-else block, if-else statement, and can be used for simpler branching, for example to control the output or assignment to a variable. This is a very handy operator. For example, int x is equal to 3 and boolean even. This is a variable, and we decide if 3% of 2 is equal to 0. If it is true, even will be true. If it is false, even will be false. And switch statement. Switch statements, there are various situations when you have to choose between multiple fixed options, only suitable for fixed options, not for the ranges of values. If you are going to compare ranges of values, you have to use if-else statements. The criteria used to select the option to execute can be an integer, byte, short, character, enum, or a string. String is introduced in JDK 7 for the switch statements. Based on switch expression or a value, associated case statement will execute. The break statement is used to break the execution of the selected case block. Otherwise, the next case will execute. Switch statements can also be nested. There can be at most one default block. Every switch statement can have at most one default case block that must execute if no other case block is selected for execution. So this is the general format, and this is the flow chart. Okay, so this is starts with the switch keyword, and inside the parentheses we will enter a value or some expression that evaluates to some constant value, and that value is matched for the cases. If it matches case 1, its block will be executed. Break statement will exit the switch statement and stop execution of the next blocks. Same way, if this expression or value matches case 2, this block will execute. If no case will match, default will execute. And if we don't put break statement here, this will fall down to the next execution of case 2. So case 1 executes and case 2 executes. And if this break statement is not there, then default will also execute. So it will trickle down like this. This is the flow chart. So it starts with switch and we pass a value and it matches the cases. If a case is matched, its statement will execute. If no case matches, default will execute and it will go to the next statement or end of the program. Variable scope. Variable scope is very important in Java programming. In almost every programming, variable scope is like a you can say a space where a variable is visible or accessible. Variable scope is an important concept that defines the scope where a variable can be referenced or accessible. There are various scopes in a Java program. For example, block level scope. A variable is only visible or accessible within a block, such as an if statement, loop, function, or a block of code. A variable must be declared before it can be referenced or used. This is mandatory. You must declare and even initialize a variable before you can use it within the program. The variable declared is an in and outer block is accessible and visible in inner blocks, but the variable declared within the inner block are not visible outside of that particular block. So that's all, guys. Let's begin coding. Hello guys, let's practice lecture 8 concepts: ternary operator and switch statement and variable scope. Let's create a class. Lecture 8, ternary operator. Clean this up and now create another class. Let's name it switch statement. Lecture 8, switch statement, and another for the third concept, variable scope. Lecture 8, variable scope. Okay, clean this up and this one too. Okay, let's begin with ternary operator. Ternary operator. Let's add main method, and this is the format of ternary operator. Operator format, that is condition and true class, and that is false class. Okay, we need 3 operands. If the condition is true, this will operate. If the condition is false, this will operate. So let's create some kind of comparison. Let's say we run let's say we have a number x is equal to 5. Okay, so and we want to determine this is a boolean number, this is an even number. Boolean even is equal to condition 5 percentage of 2 is equal to 0. This is a logical operation and it evaluates to true or false. So if it is true, and we have value of true, otherwise we will set it to false. Let's print it. Value of x is equal to 5 is even. Okay, even. So it's supposed to print false. Let's test it. Okay, it is false because 5 is not an odd number, sorry, even number. So it will set the even to false. This class will be stored. So ternary operator is used for various short or limited branching, mostly to assign values or to output something. Instead of using if-else statements, we can use ternary operator. It is useful in various small branching. We can output different things and we can do a lot of stuff with this operator. Okay, let's go with switch statement. Main. Okay, now switch statement. Switch statement is useful for the selection of certain branches with a fixed value. Fixed value is important in switch statement. So the good use of switch statement is like calling different operations or methods based on the menu selection. For example, let's write a simple menu loop to interact with the user. Okay, let's say we have a function. Ignore the do while. I will explain it in the next lecture. Do while, and let's say we have a choice int choice is equal to 0 and choice is less than 0 or choice is greater than, let's say, 3. So we will repeat it. I will explain the anatomy of do while loop in next lectures. I think lecture 9 or 10. Okay. Import java.util.scanner to interact with the user. Create scanner object, scanner keyboard, new scanner, system.in. Close the scanner to release resources. Keyboard.close. Okay, print the menu. Select option 1. Let's say A. Number 2, select option B. Select option C. And 0 for exit. Now read. Enter option. Okay, now choice is equal to keyboard next int. So we will read the input from the user. Okay, now we switch the statement. Choice. Okay, switch is based on cases. Case 1, option A selected, and we must break it. If we don't break it, it will trickle down to the next case and execute that one too. Option B selected, break. Case 3, system S out, option C selected. And let's add default to understand how default work. S out, default is selected. Okay, now let's break it. Run it. Don't need anything else. Okay, run. So the menu will be displayed and we enter our option. Let's say 1. So option A is selected. Let me see why it is. If less than 0, okay. Okay, we need to break it here, only in case of 0. Okay, let's run it again. It will repeat now until we enter 0. Okay, 1. So it will print option A selected. So how it works? It works. Choice takes, a switch takes the value of choice and compare it with the case labels, and it find this matching case and execute it. And this break statement exits the switch statement. If we enter 2, it will match this one and skip it, and then it is exact match. So we find this value to be printed on the console screen. If we enter 3, this case will be executed. In case of no matches, no case matches, this will display. Let's experience. Let's say we enter 5. So 5 entered default case because there is no case label with 5. Similarly, these are integer labels. We can use characters, we can use enums, we can use strings, and these data types can be used as a case expression and label. And switch, one thing is important to understand about the case, so switch and case. In if we have values that are exact values, for example these choices, for example some other value that is exact, for example months, for example days, we can use switch statements. We can also use if else, but if else is more appropriate if we have ranges of values. For example, if we want to execute this statement in case choice is equal to a range of numbers, for example 1 to 10. So if we want to run this code, if we use switch, we have to place 10 cases to execute this value. So that will be inappropriate. So if else will be the better choice. In case of constant values or unique and exact values or fixed values, switch is a preferable choice. It is best usable for the menu driven applications. Let's move to variable scope. Let's add main method. Okay, so variable scope. Variable scope is very important. There are various scopes. I'm not talking about classes and subclasses and other things and package level access, because I have not discussed in any lecture so far about the object-oriented programming. I will discuss those in the section 5, I think. So so far or at this level, it is better to understand the variable within a method. So understand this. This block statement. This block statement is the scope. For example, if we declare int I is equal to 5, let's say, int j is equal to, let's say 10. This I is available within this block, but this j is not available outside of this block. Let's experience. I is equal to I and j is available. Okay, let's say I accessible here, and I also accessible here. Outside, let's say inside, j is available here, j accessible here, inside. J is not accessible here, plus j. It is a syntax error because compiler cannot understand variable j. It is undefined here because it has a limited scope. Same way, let's remove it. Let's run it. Okay, I is accessible at this level. J is accessible. Yes, J is accessible here. I is accessible outside the block. Yes, it is available outside the block. So now, if we, let's say we have a loop here for int x is equal to 0, x is less than 10, x plus plus. Okay, we define j here. So x multiplied by j. Now let's say we just print j value. Okay, so j is accessible within the block of for loop. but it is not available outside of for loop. It is not accessible. And let's say we have this 5 is I is available within the block because it is outside of the outer block, outside of the for loop block. Okay, same way let's say we have if x is equal to 5, another level. So we declare a variable here int, let's say that y is equal to 5 or 3. So y is available here, y is here, but it is not available at this level. Y is not here. Why? Because it is enclosed within the if block. So this is how variable scope works. The rule of thumb. Number 1, must declare a variable before you use it. Number 2, you must consider the scope of variable. Outer space variable is visible within inner scope. Number 4, inner scope variable is not accessible outside of that scope, or say inside outer scope. So these are basic points. You must understand these points so that you can avoid syntax errors. Thank you guys. That is all for this lecture, and see you in the next lecture. Thank you. Have a good day. Hello guys. Welcome to Java Core Programming course. This is section 2 and lecture 9. Today's agenda: loops, for loop, enhanced for loop, and nested loops. Let's begin. Loops. In Java programming, loop is a sequence of instructions that repeatedly executes a statement or a block of statements until a certain condition is met to stop execution. Java supports 4 kinds of loops. Basically 2 types of code loops. 2 are the variation of for loop and 2 are the variation of while loop. So total 4 loops. For loop, this is a standard conventional loop. Enhanced for loop is for collections like arrays or lists or other similar collections. We will discuss this more in future lectures. While loop. While loop is also a conventional loop. It is used when you do not know how many times you have to run the statement or block of statement. Do while loop. Do while loop is the variation of while loop. It executes the body of the loop before the condition is evaluated. Generally, a loop has 2 parts: loop body, statement or statements to execute repeatedly, and control mechanism to control the loop repetition and how many times it's supposed to run. This is control mechanism. If this mechanism is not there, the loop will run infinitely. So we have to control the execution. So for loop, this is the flow chart. This is how it works: start, initialize, loop condition checked, and if the condition is true, it executes the statements, then it increment or decrement and go back to the loop condition to evaluate it for the next iteration. Once this becomes false, it go to the next statement and the loop ends. So traditional for loop is like this. for, initialization, condition, increment and decrement. Within the body of the loop there are statements. If there is a single statement, you can skip using curly braces. So the loop body is enclosed within the curly braces. If there is a single statement, you can omit braces. Loop control mechanism is within the parenthesis here, starting from here up to here, and it has three components. Initialization, here we will initialize the loop invariant. This is the condition. This is evaluated for each iteration. If this is true, the body is executed. If this is false, the body is not executed. Increment and decrement. Here we will control the loop invariant that we initialized here. We increase it and decrease it. And based on this increment and decrement, this condition is evaluated true or false. Loops start with initialization. Condition is checked. If evaluated true, loop body executes. Then the increment and decrement part is executed. After the increment and decrement, loop condition is checked. This process is repeated until the condition is true. So this loop is used when you normally know in advance how many times it has to execute. So that is why we also call it counting for loop. Enhanced for loop. Enhanced for loop is especially designed for collections or arrays. We will work on this loop in future lectures. So it works like this. We start, declare the loop identifier within the parenthesis of for loop, and it checks end of collection is reached. If the end of collection is not reached, it goes to execute the next item and execute statements. And if end of collection is reached, it go to next statement and stop the execution. So enhanced for loop is introduced in Java since Java 1.5 when the Java generics are introduced in the Java generics are introduced in Java 1.5. This is a similar loop as the for loop in C# and VB.NET and for in loop in Python. Only works with arrays and collections. We study them in future lectures. Okay, this is the general syntax. In the general syntax, for loop parenthesis start, data type identifier, and colon. This colon refer to collection. Then executes the statements. This data type is initialized here. Then the collection is checked whether it is reached end of the collection or not. If not, execute the statements. Identifier is refer to the object in the collection, and this is current object within the collection during the iteration of this for loop. This loop executes once for each element in the collection or array. Now the nested for loops. We can nest loops, loop within a loop. Any loop can be nested into another loop. We can nest for loop into while loop into for loop, and similarly do while loop. Nested loops are commonly used for sorting, handling multi-dimensional arrays, and drawing different shapes, and processing other mathematical logics. To test the nested loops, I will show you different programs like display a triangular shape, a box of some character, computing a number raised to its power etc. or some other programs, just to practice the nested loops. And this is general syntax. For example, I have nested two for loops here. This is first outer for loop, initialize, condition, increment, decrement, parenthesis, and within the parenthesis there is another loop. Same syntax. This loops runs, for example, n times, and for each iteration of this loop will execute, and this is how we nest the different loops. And for this loop we can use while or do while, and we can also use while and do while here, and inside it for loop. So any loop can be nested into other loop. Thank you guys. Let's practice the concepts. Hello guys, let's practice for the concepts of lecture 9: for loop, enhanced for loop, and nested loop. Let's begin. Let's create files. First Java class, lecture 9, for loop. Lecture 9, enhanced for loop. And last one, lecture 9, nested loops. Okay, we begin. Let's format the files. And lecture 9 for loop. And this one, this one, this one. Let's begin with the for loop. So let's add main method and for loop. Is a conventional loop is also called counting loop. For example, we have int x is equal to 0, x is less than equal to, let's start with 1, is equal to 10, and x plus plus. It has 3 components: initialization, and this is the loop condition. It will check x is less than equal to 10, and if it is true, it executes the body of the for loop, and once it is completed, it increments the x loop invariant and come back into this position to check for the x position against 10. So let's print it out. Value of x is equal to x. So this loop will execute 10 times. Okay, we can add different branching inside the loop to check. For example, in case we want to print only even numbers, only even numbers. Okay, if x percentage of 2 is equal to 0, and this condition will filter the numbers and display only even numbers. Okay, these are only even numbers printed here because of this condition. So this way we can write the loop, control it with our conditions, and execute the loop body and filter out our results. Same way we can write different logic based on our requirements. Let's move to enhanced loop. Let's add main method. Now enhanced for loop only works with arrays and collections. So let's declare an array. We will study array in future lectures. So integer array, int array is equal to, let's say, 2, 3, 9, 11 and 15. Okay, now we have 2 ways to iterate this array. For example, we can use conventional index base access and counting loop. counting loop. So we can do this int x I0, I is less than array dot length I plus plus, and we print here, let's say array 0 is equal to %d, and this is I, array I. This will print the subscript of the array and its associated value. Let's test it. See, array 0 is 2 and array 1, 2, 3, 4, these values. Now let's use an enhanced loop. For integer I, and this is the syntax for this one, s out and value of let's remove the, because we don't have access to the index now. So array element is stored inside it directly, and we can print it. Let's print it like %d and I. Enhanced for loop. Okay, so our array is printed without accessing the individual subtracted element. So this loop basically works like this. It iterates the array, store the current element into this variable, and this variable is directly accessible within the loop body, and this points to the current element. In first iteration it points to 2, second iteration it points to 3. In the same way it iterates entire array and store these elements one by one into this variable. This loop can be very useful, especially while working with the collection objects. For example, array list and sets and other things. I will use this loop frequently when I will make the lectures for Java collections. Stay tuned, they will be posted soon. Okay, now very important, nested loops. Let's add main method. Okay, nested loop, a loop within another loop. We can do lot of things using nesting. Loops can be nested to any extent. Let's draw box of, let's say, characters. So int size is equal to 10. For int I0, I is less than size I plus plus, and we are nesting another loop inside the for loop. Int j is equal to 0, j is less than size j plus plus, and we print this character 10 times on a single line. And we print new line after execution of this loop, the inner loop. This is outer loop. What this will do? This will print 10 characters at a line and make a box of it. See. So we can control the output. Let's draw a triangle. Keep everything like this and just copy these two loops and place a condition here. For example, we can do if j is less than equal to I. It only prints as many numbers as many times as the upper loop variant. So this will print a triangle. See, this is a triangle printed here, right triangle. Okay, we can let's say print a hollow box. So let's copy all this, place it here. Hollow box. Okay, so what we need? We need to place different conditions to control the output. So first condition is if I is equal to 0, so it must print the first line, or I is less than size minus 1. So this will print the top line, top row and the bottom row. Okay, now or let's print it first and we will see what is the output. I is equal to 0 or I is less than, sorry, I is equal to this one, and we print. So, and otherwise we print the new line. Okay, let's see what happens. So we have this printed, top row and the bottom row. Now what we want is print this column and print the last column and keep the center space is empty. Okay, so if let's say let's mix the conditions and j, 1 minute. So what we need is we need to print this one, and between the empty spaces, so we will make it like r j is equal to 0. Whenever j is equal to 0, print this line. This character will be printed whenever j is equal to 0. Next condition is or j is equal to size minus 1. This will print this column, last column, and otherwise print space. Okay, run it. 1 minute. Okay, run it. So this is printed like this, hollow box. Now let's add another thing. We will add a cross. This is hollow box, and copy it, and a hollow box with cross. We will put a character in the diagonals. So we will add condition or I is equal to j. Okay, so what will happen with this? Run the file. So this has printed the diagonal. Now we will add another condition to print this diagonal. So this diagonal will be equal to I is equal to, sorry, so we need another condition to print the other diagonal. So j is equal to size minus I minus 1. Okay, I think this will do the trick. Run file. Yes, it is done. So we can print the hello screen with the cross with this logic. This is a composite logic, and with this practice you can learn a lot about how the loops work and how you can control the loop with the conditions. Thank you guys, that is all for today, and I hope you have learned nested loops, loop, for loop and enhanced loops. And if you have any question, drop me a message, I will answer. And keep practice. Practice will make you a best coder. See you guys in the next video. Have a good day. Please subscribe to the channel and promote the content. Have a good day. Hello guys, welcome to Java Core Programming course. This is section 2 and lecture number 10. And today's agenda, we are going to discuss while loop, do while loop, break statement and continue statement. Let's begin. While loop. This is the flowchart for the live while loop, and this is the general syntax. You see that while loop starts with the while keyword, and inside the parenthesis there is a Boolean expression that will be the condition of the loop. If it is evaluated true, the loop body will be executed. Let's see the flowchart. This is the start of the program and start of the while loop, and this is the decision inside this parenthesis that is evaluated. It is an logical expression. If it evaluates to true, and the process or the statements will be executed, and it goes back to the decision, and this continues as long as the condition or the decision is true. Once it becomes false, it goes to the next statement and the loop iteration stops. While loop is controlled by the logical expression to take decision. As long as condition is true, it executes the body of the loop. Once the condition evaluates to false, it exits the loop and goes to the next statement. Care is required. This is very important to ultimately make the logical expression evaluates to false. This condition, it must converge to be false. If this is not false, this loop will become infinite and will never ends. So it has to stop at some point during the execution of the program, so that the program continue its normal execution. So we will make the condition false within the body of the loop. Usage. We normally use while loop when we do not know in advance how many times it's supposed to execute. So while loop executes 0 or more times. Now the do while loop. Do while loop is the variation of while loop. In this loop, the body of the loop executes first, then the condition is evaluated. If it is true, the body is executed again and come back to the decision. Till the decision is true, this process repeats. Once the decision becomes false, it goes to the next statement and stop iteration of the loop. So this is the general syntax. Do, body of the statements, body of the loop having statements executed, and then the while checks the condition and evaluates the logical expression to see if it is true or false. If it is true, it executes it again. If it is false, it stops and goes to the next statement. It is variation of while loop. It executes the loop body first, then checks the condition. it executes at least once, no matter that loop condition is true or false. So we use it when we need or we want to execute the body at least once, and it is good to use this loop for the menu driven programs, and we display the menu to the user within the do while loop, so it executes at least once and show the menu. If the user selects exit, the while loop ends. Continue statement. Continuous statement is a loop control statement. A loop control statement is helpful to control the loop. Continuous statement uses continue keyword. It breaks the current iteration of the loop and starts over to the next iteration. So we use it when we want to skip the current iteration of the loop and want to start the next iteration. So there are two variations of the continuous statement. In first variation is, this is a loop. It can be while, do while, or for loop, any loop, and this is a condition because we conditionally stop iteration of the current loop. So if the condition is true, we place continue keyword here, and this continuous keyword stop the loop iteration and does not execute anything after this block and go to the next iteration. Or we can also use this same statement with the we can this is example, and I will show you the variation of this iteration in the next slide. I might be so for loop, it starts with 1, iterated up to 10, and increment 1 by 1, and if the loop invariant I is an even number, continue. That means this iteration will be stopped and it goes to the next number and increase the I and check the condition. So this loop will only print odd numbers. It does not print even numbers because it skipped the iteration of the even number. So this is the second variation. In the second variation, we can use labels. Labels are ways we place with a named location within the program with a colon, and we can move the execution to that particular label by using continue statement. So the break statement. Break is also a loop control statement. Break statement normally used in switch statement to break the execution of a selected block so that the execution of the next block should not be executed or started. This same break statement we can use within the loop to stop or exit the iteration. This statement does not just stop the iteration of the current iteration. If this statement is placed within the loop, it breaks the loop. Normally it is discouraged because this is not a good practice to use break statement to exit the loop. So it is encouraged to use a Boolean expression or a condition to end the or to stop the loop execution. It is in the case of loops, it terminates the loop. This is different from continue. Continue only skip the current iteration. Break does not break the current iteration, it just breaks the entire loop. This is the general syntax. Loop, statements, condition. If the condition is true, break. This will break the loop. While, for example, while I is less than or equal to 100, sum it. If the sum is greater than 100, break. So we know that sum of 1 to 100 is equal to 5500. So we only want the sum up to 100. So sum is, we add I to the sum. If sum becomes greater than 100, we break it. So this will break the entire loop, not just the current iteration. That is all, guys. Let's begin practice. Hello guys, let's practice. Lecture 10 concepts: while loop, do while loop, break statement, and continue statement. Let's begin. Let's create classes for the practice. First, while loop, lecture 10. And do while loop, and next we will do statements: break and continue, break, continue statements. Okay, remove this. Okay guys, let's start with the while loop. Add main method. Okay, while loop, two components, condition and loop body. So this is general syntax: while, condition and loop body. Okay, so we can use any logical expression here that will be evaluated to true or false, and based on the result, either the body of the loop will be executed or skipped. So let's say we want to print 10 numbers while I is less than equal to 10. I is equal to I. Let's print it. So this loop will print. Okay, we need to increment it, sorry, to make the condition false at certain time, I plus plus. Otherwise it will run infinitely. Okay, now this will run 10 times. Let's do a loop with the condition. Okay, let's say int input is equal to 0 while input is not equal to, let's say, -1. Import scanner to interact with the keyboard. java.util.scanner. Create object. Scanner, keyboard, new scanner, system.in. Okay, now here let's say int sum is equal to 0. Okay, prompt the user to enter a number. Enter a number to add or -1 to exit. So -1 will be over sentinel condition. Okay, input is equal to keyboard dot next int. If input is not equal to -1, with sum plus is equal to input. Let's print it. Sum is now sum. Okay, let's run it. This loop will execute as long as we enter -1. Sorry, as long as we enter any number other than -1. So let's say 1, and we add 2, and we add 5, and we add 10, and we add -1. This will exit. This is how we make a while loop and run it as many times as we want until the condition is true. Let's do the while loop. Okay. Let's see, this printed the line 10 times. Okay, let's do it again. Is equal to 1, do while I is less than equal to 10. Okay, now print it. I is equal to s out do while loop plus I. Okay, increment I plus plus. Let's run it. Okay, it ran 10 times. Okay, let's make the condition false. Is equal to I is equal to 0, or let's say while I is less than 1, but here I is equal to 1. Let's make it new loop. So I is equal to 1, and we want to run this loop at least one time, no matter the condition is less than 1. At least once. Okay, let's try this. Okay, see here, do while loop at least once. Look at the condition. I's value is 1. We printed this line. We entered into the loop body. We printed this line, incremented it, and checked the condition. I is less than 1, and it is false, so exit it. So I is equal to 1 here. This condition is already false, but still it executes at least once. Do while loop must run at least once, no matter the condition is true or false. Okay, where we use mostly main. Mostly we use do while in menu driven programs. Okay, I wrote a code here. I think this is do while loop. Okay, let's copy it. Do while. Okay, look at this. We started with the choice that is 0, and we printed the menu, and we read the choice from the user, and this is do while loop. It execute at least once and keep on executing as long as we enter 0 to exit the loop. So we print the choice. Accordingly, output will be shown, and this will run as long as we want it. For example, let's run it once. Run, and here let's enter 0. Okay, default is selected and loop is exited. Let's remove this to make it more clear. It ran even though the choice has no value, and it is not initialized, and menu printed, user input read, choice is equal to set to the user input, switch statement entered, and no value of the case matched, so default will be executed, and do while loop exits because we have entered 0. This default is selected. This way. So this is how do while loop works. It runs at least once, no matter the condition is false, because this loop executes the body of the loop first, then it checks the condition, and if the condition is true, it executes the body again, otherwise it goes to the next statement. Now the break and continue statements. Main. Okay, let's run a loop to only print even numbers using continue. Okay, for int I is equal to 1, I is less than equal to 10, and I plus plus, and we put condition here, condition to check odd number, condition to check even number with the odd number. If I percentage of 2 is not equal to 0, and we continue, otherwise print value of I is, let's say, even value I. Let's run it. Okay, so we see it only printed the even numbers, because whenever it is odd, it continue. What does continue do? When the loop condition is true, it enters into the loop body. This condition checks if the i's value is odd and encounter the continue loop. Continue loop breaks the current iteration, and it goes to the increment section and then goes to the condition check and continues. If it is even, skip this and print this. This is how it works. What happens if we use break statement? Example, continue statement. Let's copy it. Okay, now run a loop to only print even numbers using and use break statement. Okay, we place break here. If a number is not even, we break. What does break do? Break will terminate the entire loop. The first number, let's say first number is 2, so at least we want one number. Okay, let's run it to understand how it works. So guys, example, this statement is printed, loop started with 2, and this is an even number, so this will skip the if block and print this one. It goes to the increment, make the value of I is equal to 3, that is an odd number, and enters into the if block and break the loop. Nothing else will happen. It breaks the entire loop. Continue only breaks the current iteration of the loop. This is how break and continue works. It is good to use continue statement if we want to skip some iteration. It is not a good practice. Not a good practice to use except switch case statements. So always make a boolean condition to exit the loop instead of using break statement. It is a bad programming. Thank you guys. That is all for today, and hope to see you in the next section. Take care. Please subscribe to the channel and promote the content. Have a very good day.